So in today's lesson, we're going to be talking about the slope formula. So if you recall from our last lesson, slope is equal to rise over run, which we also said was the change in y, right? Change in y over the change in x, right? So how do we find the rise and how do we find the run? So the run is always going to be how high off the ground this is, and then how that is, right? So you're going to find that point of intersection right here. You're going to find, okay, how many x's did I go over? I went over 1, 2, 3, 4, 5, 6. Went over 6 x's. And I went up 1, 2, 3, 4, 5, 6, 7. I went up 7, and I know my scales are all up by 1, which is why I can count like that. So my rise is going to be that change in y. So my rise is going to equal plus 7 because I'm going up. So it's plus 7 over, and since I'm going to the right, I'm going plus 6. Rise over run. So slope is equal to 7 over 6. So we're going to determine today a formula for slope. When we're determining the formula for slope, the reason that we're going to do this is because you might not always have a graph or graphing paper in order to determine what the slope is. So you might not always have a physical picture of the line in front of you. Instead, I might give you coordinated points or something like that. When you're given a situation like that, you still want to be able to find the rise over run. So if you're given a situation like this, we're going to determine the slope formula together. So say I had this line segment PQ, right? And it had x1, y1, x2, y2. And I wanted to determine, all right, I want to now know what is the slope of this line PQ. First things first, I'm going to want to find the change in x. So delta x. How can I find the change in x? I could count, but since I don't have the ability to do that now, right, I could, for example, have gone back up here to find the change in x. I could have gone, okay, what is my x value? 8. What's my x value here? 2. And I could say, okay, so if I'm going from a 2 value of x to an 8 value of x, I must be going over 6 points. Using that same logic, what I could say is that if I wanted to find out what the difference between x2 and x1 is, I could just do x2 minus x1. And that will give me my run. If I wanted to find, so x2 minus x1. If I wanted to find my delta y, same logic, I could say, okay, I started here and I'm going up here. What's the change in between these? y2 minus y1. Right? So that would be my rise. So if I know that slope is equal to rise over run, and I know that rise is equal to delta y and run is equal to delta x, I also know that delta y is the same thing as saying y2 minus y1 over x2 minus x1, because that's a change in x. I can say my slope formula is this, right? And then we use m to represent slope. So we write it as m is equal to y2 minus y1 over x2 minus x1, which is the same thing as saying rise over run. I'm just going to go in and I'm going to make a nice box around here. Okay, and that is my formula for slope. Alrighty. So if I know this now, determining the slope of a line passing through points, I can do this without having to know what the line looks like. I can simply go in here and say, okay, these are going to be my first point. So this is going to be x1. This is going to be y1 because this is x. This is my first point. This is going to be my second point. So it'll be x2, y2, right? Because in a coordinated pair, it's always x's and y's. And I'm just going to start plugging numbers in. So I'm going to say slope is equal to y2 minus y1 over x2 minus x1 is equal to y2 here is 2 minus 4 over 8 minus 3, which is equal to, so I'm just going to carry this over to the other side. 2 minus 4 is going to give me negative 2. 8 minus 3 is 5, right? So my slope is equal to negative 2 over 5. Okay? So I want you to try doing B and C and D on your own. They are a little bit more complicated. Well, D is more complicated because anything that involves fractions automatically becomes more complicated. But I want you to try those out by yourself. So put this on pause, come back and watch. So hopefully you try those by yourself. We're going to do this again, right? So I'm just going to start off and I'm going to say, all right, what's my x1 and what's my y2? Or what's my x1, y1 and what's my y2, y1? So I'm going to make these ones my first point, right? And I'm going to make these ones my second point. Okay? So let's make this x1, y1. And this is going to be x2, y2. Okay, and I'm just going to go plug that back into that formula. So m equals y2 minus y1 over x2 minus x1. So I'm going to take the x2, which is, I'm going to take the y2, which in this situation is negative 2, minus, and you have to put the minus in first, brackets, and then I have 6 right here. It's a positive 6, right? So negative 2 minus positive 6, 4 minus negative 2, right? And then we're just going to solve. We're going to say, okay, negative 2 minus 6 divided by 4. Negative plus a negative becomes a positive, equals negative 2 minus 6 is just negative 8. 4 plus 2. 4 plus 2 is going to give me 6. So I have negative 8 over 6, so I can change that to 4 over 3. It's negative 4 over 3. Okay. Alrighty. Moving onwards. Hopefully you tried C as well, right? We're going to do the same thing. I'm going to say, all right, this plot is going to be my x1 and my y1. This plot is going to be my x2. Maybe I'll do that in a different color in case you'd like to see that. This is going to be my x2, y2, right? And slope is equal to y2 minus y1 divided by, so I'm just going to put the minus in, x2 minus x1. So I'm basically taking this green point and minusing it from the red point. Okay. So I'm just going to go back and plug my values. So I have negative 2 minus 4 divided by negative 2 minus, oops, sorry. This should be negative 2 minus 7. That's why you got to be careful. So then I have negative 5 minus 4. Negative 2 minus 7 is going to be negative 9. divided by negative 5 minus negative 4 is going to be negative 9. Negative 9 divided by negative 9, the negatives cancel out, the 9 and the 9 cancel out, so I'm left with positive 1. All right. D is just a little bit more complicated because now we got to work with fractions. So I like to split this up, right? And I'm going to say, okay, rise is equal to y2 minus y1. And I'll do run is equal to x2 minus x1. Right, so let's do y2 minus y1. So we have 5 over 2 minus 3 over 4. I got to change this 5 over 2 into over 4. So I can do that by multiplying both sides by 2, or both numbers by 2. So the 5 over 2 becomes a 10 over 4, right? This is 3 over 4, so I can just leave it as is. You have to do this step when you're adding and subtracting fractions. It's like mandatory. So 10 minus 3 is 7 over 4. Okay, we're going to do the same thing for a run. So for our run, it was negative 2 over 3 minus 1 over 2, right? Got to change these to equivalent fractions, so I'm going to put them all over 6. Remember the minus sign in the middle. So in order to get from 3 to 6, I multiplied by 2, so I'm going to multiply the top by 2 as well. 2 times 2 is 4. In order to get from 2 to 6, I multiplied by 3, so I'm going to multiply the top by 3. Right? So notice how 3 over 6 is the same thing as saying 1 over 2. Same thing here. 2 over 3 is the same thing as saying negative. Remember that negative. Negative 2 over 3 is the same thing as saying negative 4 over 6. So now I'm just going to do this. Negative 4 minus 3 over 6. Negative 4 minus 3 is going to give me negative 5 over 6. Oh, sorry, negative 7 over 6. Woo! This is why you don't take shortcuts in math. Right, so I have negative 7 over 6. So I have 7 over 4 and negative 7 over 6. So I know what my run is, I know what my rise is. So I'm going to have m is equal to rise over run. So I'm going to have 7 over 4 divided by negative 7 over 6. I hate the way this looks. So I'm going to do m is equal to 7 over 4. Let's just do it this way. Divided by negative 7 over 6. And then I'm just going to divide my fraction. So I'm going to do m over 7 over 4. Keep, change the sign, flip the fraction. Right? I can just go in and cancel. I can go in and do 3 and 2. So I'm left with m is equal to 3 over 2. And that's my answer. That's a more of a step-by-step way of doing that. Okay? So I'm going to move on. So now I'm going to go through, draw a line that passes through the given points, right? Pass through the given points at a given slope. So this is a little bit more complicated. What is the slope 2 over 5 actually trying to say? What the slope means, or actually let's do A obviously. What the slope means, 1 over 4, negative 1 over 4. 1, the negative means it's going down. The negative 1 is the change in y, so it must be going down 1. Down 1. And then the 4 means run, so how much is it going over? 4. So down 1 over 4. And the 1 over 4 kind of just gives us a starting point. So let's go and find 1. 1, 2, 3, 4. So this is going down 1. So I'm going to go down 1 over 1, 2, 3, 1, 2, 3, 4 to 5. So I'm going to put my second point there. Okay, so down 1, down 1. So I started here, 1 and 4, down 1 over 1, 2, 3, 4. So I'm going to put my point there. Okay. So I'm going to do the same thing. I'm going to go down 1, 1, 2, 3, 4, and then keep going. Down 1, 1, 2, 3, 4 until you can't. Then what I'm going to do is I have 3 points in, so I'm just going to go in and draw this line with a ruler. And again, like I said, your lines will be better than mine because I don't have a ruler to draw with. But it'll look something like this. All right, and if it's a straight line drawn with a ruler, it'll go through the right points. So how about you try B by yourself, right? Your starting point is going to be this -2, 1, right? And the slope of 2 over 5. So remember, it means rise over run. And try it out by yourself. When you come back, we'll take it up together. So pause this video. Try it out. And we're back. Okay? So hopefully you paused and you came back. Okay? So let's just go off to our starting point. It says -2 and 1. So I'm just going to go put in that dot. What does this mean? It means, so since this is a positive, it means up 2 over 5. So I'm going to go to this point and I'm going to say up 2, 1, 2, over 5, 1, 2, 3, 4, 5. And I'll put my next dot here. Same thing, I'm going to go from here, I'm going to go 1, 2, over 5, 1, 2, 3, 4, 5. And I'm going to put my dot there. I'm going to do 1, 2, 1, 2, and I'm going to keep going. And I'm just going to go and draw in a line connecting those 2 or 3 dots and just to infinity. Okay? And that's what that's going to look like. So for your test or quiz, know how to draw these. Know how to use the dot and figure out where you're going or using the slope. So our next point here is going to be example 3. So example 3 is asking us, the following are coordinates A, B, and C, right? So you have these coordinates, they're A, B, and C. They're segments of a line. It says to determine the following of each of these coordinates. So let's do line segment A, B first. So I'm just going to go in and I'm going to say, okay, line segment A is going to be my x1, y1. Which means that my x1 is going to be 2, my y1 is going to be 1. And segment B, and I'll just put it in green, segment B will be my x2, y2. Right? Because in theory, if my segment looks like this, I'll have A and B. So that's what my coordinates are going to look like that. Okay? So I'm going to say segment B is 4 and 5. So I'm just going to go in and find the slope. M is equal to y2 minus y1 over x2 minus x1, which is equal to y2 is 5, y1 is 1, x2 is 4, x1 is 2, negative 5, and 5 minus 1 is just 4. 4 minus 2 is just 2, which is 4 over 2 is equal to 2. Therefore, M equals 2. And I'm just going to go, because I like to always be neat, I'm going to go in and highlight that. Okay, then it's asking me to find line segment A and C. So I'm going to go back here and I'm going to say, okay, what are the coordinates for A? And that'll just be my x1, x2. What are my coordinates for C? That'll be my y1. My x2, y2. Right, so this is my x1, y1. It's my first coordinate. Then my second coordinate is going to be here. And I'm just going to go put the numbers in. M is equal to y2 minus y1 over x2 minus x1. So I'm going to find my y2, which is 9, minus 1. x2 is 6 minus 2. 9 minus 1 is just 8. 6 minus 2 is 4. 8 divided by 4 is 2. So I'm going to say my m is equal to 2. And again, I just like to keep it neat, and I'm going to highlight that. I'm going to do the same thing for B and C. So try this one by yourself if you kind of figured out the pattern here. B is equal to 4 and 5. C is 6 and 9. Right? So I'm going to do, this is x1, y1, x2, y2. I'm just going to go start plugging stuff in. M is equal to y2 minus y1 over x2 minus x1 equals y2 is 9, y1 is 5, x2 is 6, x1 is 4, 9 minus 5 is 4, 6 minus 4, sorry, I forgot to put the minus sign in there, 6 minus 4 is 2, 4 divided by 2 is 2, so m is equal to 2. So it asks us, what do you notice? M is equal to 2, m is equal to 2, m is equal to 2. All the slopes for the line segments are the same. So it's safe to assume that since all these slopes are the same, these lines, right, because there's line segment A, there's line segment AC, there's line segment BC, all of these lines are collinear, which basically means that they all lie on the same line. So if you plotted these 3 points on a grid, one line would pass through all 3 points, right? And you can try doing that. Put in all these points and you'll see that they all pass through the same line. Okay? So example 4 is one of those, like, those thinking and inquiry, like, are you actually understanding this? Do you get what's happening kind of questions. So try doing example 4 by yourself and then come back and we can take it up together. So it says here that the slope of a line is 4. The line passes through the point A, which is negative 2k, and B, which is 6 and 12. Right? We want to find out what the value of this k value is. What's the value of k? I want to know what that number is. So the first thing I'm going to determine is, what's the equation for slope? M equals y2 minus y1 over x2 minus x1. Right? Always going to be that. Let's start to go put in these numbers. So I have x1, y1, x2, y2, and my slope here. Let's just start plugging in numbers. So I'm going to put in 4. I always like to put it over 1 if I'm working with fractions. I'm just going to put it 4 over 1 is equal to y2, which is just 12, right, minus k over 6 minus negative 2. So I'm going to do 4 over 1. Maybe I'll leave the over 1 for now, just so that it doesn't become annoying in the future. So 4 is equal to 12 minus k. And just solve that bottom one. 6 plus 2 is going to give me 8. Right? Now I just got to isolate for k, and we've already been doing this, so let's get rid of that 8 on both sides. Go all the way up here. 8 times 4 is just going to give me 32. 32 is equal to 12 minus k, right? I want to get the k by itself, so I'm going to bring the 12 over. So 32 minus 12 equals 12 minus 12 minus k. 12 minus 12 cancels each other out. 32 minus 12 will give me 20. I'm left with negative k. I want to get rid of that negative, so I'm going to divide both sides by negative 1. 20 divided by negative 1 gives me negative 20 equals k. Therefore, my A coordinate passes through negative 2 and negative 20, right? So if I really want to draw this in, I'm going to go find negative 2, negative 20. I'm going to put that A coordinate there. And then let's make our B coordinate in orange. Right, so let's make that one in orange. It says it's 6, 6, 6, 6, and 12, right? And I'm just going to draw a line through it. So I'm going to say this is what my line looks like. Right, it's a straight line. And that's how you would graph it. Okay? Alrighty. Another way you could have done this is literally, you could have just counted. You could have gone, okay, I know that the slope of my line is 4. So I can start off at 6 and 12, and I can just go down 1, 2, 3, 4, over 1, down, over 1. It's a lot more work this way, so I recommend doing it the other way, but you could have figured it out that way as well. Okay? Alrighty. That is the end of this lesson. See you tomorrow.